Okay, so this is an explanation for problem 3.2. Let me focus that right there. Okay, and what we're going to be doing in this particular problem is predicting the direction of a reaction. Here's the question in particular. What is the direction of this reaction at HCl equals 5 molar, NaOH equals 4.3 molar, NaCl equals 6 molar, and K, which is our equilibrium constant, equals 0.5. Here's the reactions that we're going to have to use, or the equations we will be using in this problem. Okay, firstly, we need to figure out what's going on here. Okay, so we have an acid, HCl, and we have a base, NaOH, and they will combine to make a salt, sodium chloride, and water is a byproduct. And I will show this in my equation that I wrote below. HCl plus NaOH equals NaCl plus H2O. Okay? Now that we know our products and our reactants and our concentrations of each respectively, and by the way, H2O, it will be assumed that it is 1 molar just by convention, okay? Just getting that out of the way. But now that we know our products and our reactants, we can actually put the products on the top and the reactants on the bottom, and these are all to the power of 1. So just assume that they are just molar concentrations here, and that's what we are actually going to write down here. So we get our reaction quotient equal to these molar concentrations to the power of 1 multiplied by each other, and that'll essentially simplify into 6 over 21.5, which was why we get a reaction quotient of about 0.279. Okay, so now we've got the reaction quotient. Where do we go from here? Well, we're going to use the free energy change equation. Yes, we're going to use the free energy change equation to actually figure out the reaction and what it would rather favor, the products or the reactants, and whether it would be shifting left or right. And the delta G is what's going to tell us this. So as you can see, I've done some mathematical acrobatics to prove that the delta G, or the standard free energy, is RT ln K. And then we have this other portion which we could already solve, except for the RT portion. We got the L and Q already. And see, we got delta G, and we could write that as simply RT ln 0.5 plus RT ln 0.279, and we can simplify that even further by just putting the RT, or putting the natural logarithms in parentheses, okay? And essentially what we'll find here, once we plug in the numbers into a calculator, we'll see that our free energy change is going to be a negative plus another negative, and well, geez, we got a negative number here. That would imply that delta G would have to be negative. Okay, very good, very good. That makes sense. And this implication, actually, since G is negative, this would cause the reaction to shift right and ultimately favor the products. So this is the problem once more, okay? And essentially from this we can deduce that this is a reaction that will shift right and favor the products. Thank you very much.